This is for electrocardiogram. Really quickly, fulfilling objective 10, which is to demonstrate and know how to determine various time measurement calculations using the ECG paper graph markings. Starting out here, we're just going to basically show a couple different methods of how to do this very quickly, very simply. This is just dealing with the time, not the volts. So starting off here, what I'm going to do is just understand that when you have these boxes, each big box is going to represent 0.2 seconds. It's going across like this. And that means that each of the small boxes represents 0.04 seconds. And so what we have is we have 0.2 seconds, 0.2 seconds, 0.2 seconds, 0.2 seconds going across. So if we were to get 5 of these together, 5 of the big boxes together, recognize that's going to represent 1 second. And so if we want to do a really quick measurement of how many beats per minute a person is going to have, all we would have to do is we'd have to take the basically the time that it takes for 6 seconds to pass, because if you remember, there's 60 seconds in a minute, and so you just take basically how many beats occurred over 6 seconds, and then you multiply that times 10, and that would tell you how many beats would occur in a minute. So, really simply, if we're looking at this, let's say this is the whole thing here, 6 seconds, and you know it's 6 seconds because you just basically count, 5 would be 1, 10 would be 2, so on and so forth. So you just count here, okay, there was 1, 2, 3, 4, 5, 6 that occurred, so 6 times 10 would be 60 beats per minute. Really simple, really obvious, straightforward way to do it. Sometimes, though, you don't have the entire strip. You have to be able to take it off of a smaller segment of time. And so if you're going to do something like that, there's another method that you can use. You can always just count the individual boxes, but that can be really time consuming. But the other method is the 300, 150, 175, 60, 50 method. And that sounds, when I first saw that, I was really overwhelmed, really confused where it is. I don't really like to, not a number person, but it really actually makes a lot of sense. What it is for this is you look at this piece of EKG paper, and you see that there is going to be these big S waves at the top here in the QRS complex. And what you're going to do is you're going to try to count the amount of big boxes between each QRS wave. And however many boxes you go over before you hit the next QRS wave, S wave rather, is going to be basically how many beats this person is going to have per minute. It's a way of calculating it. And and so looking up here, if you had let's say the person had one S wave right here, and then before the time, within the lapse of 0.2 seconds, they had a second S wave. That means that their heart's beating really fast. That's, if you were to calculate that out and look at that over, the whole 60 seconds, you would count that out at 300 beats per minute, which is, off the charts. That's ridiculous. So then if you were to say, okay, how many beats are going to occur within a minute if they are 2 boxes apart? And if these S waves are 2 boxes apart, then you would just count. Now you can start here, so you count your 0, you go 300, 150 before I get to the next spike. And so you'd say, oh, the person must have 150 beats per second. Whereas when you come down here, if you see that they're 3 boxes apart, you would say, because you started at 0 here, so 0, and then you'd say 300, 150, 100, and that would tell you the amount of beats that they have per minute. And the same thing, going down here, it just continues on. This is 4 boxes apart, so you'd start at 0 and say 300, 150, 100, 75, and it would go on. If it was another one, you could say 60. If it was another one, you'd go 50. And if you notice, it's working with fractions. The difference between these two, I guess I'll start on this end. Right here, the difference between 300 and 150 is 150. And so the first fraction here is going to be 1/2. So if you were to, if you take, you know, the 2 from the 1/2 times 150, that's going to equal 300. Over here, the difference between 150 and 100 is 50. And then since this is 1/3, if you were to take the 3 in here, 3 times 50 would be 150. Over here, the difference between 75 and 100 is 25. If you were to take 25 times 4, because it's 1/4, it would be 100. Over here, the difference between 75 and 60 is 15. 15 times 5, or 1/5, would be, not really 1/5, but the 5 and the 1/5, would be 75. And the same thing over here, the difference between 60 and 50 is 10. If you multiply times the 6 for 1/6, it would be 60. So it's just using the concept of fractions. 1/2, 1/3, 1/4, 1/5, 1/6, going down, and that's kind of the why it works. And hopefully that is helpful.